Dear students, today we discuss the Logit model in detail. This is important to understand how to interpret the results obtained from a statistical or econometric software. Now remember this, in the linear probability model, Pi was equal to expected y is equal to 1 given x is equal to beta 1 plus beta 2 xi. Pi is expected y equal to 1 given x is equal to beta 1 plus beta 2 xi. Pi is linearly related to x, and you can estimate this model using OLS. And we have discussed the problems with this model and suggested Logit and Probit as alternatives. Now suppose that we consider a specification Pi is equal to expected y is equal to 1 given x as equal to 1 by 1 plus e raised to minus of beta 1 plus beta 2 x. This functional form we have introduced in the last class. So 1 by 1 plus e raised to minus of beta 1 plus beta 2 xi. We write it as 1 by 1 plus of e raised to minus zi, where zi is equal to beta 1 plus beta 2 xi. This can be written as e raised to zi by 1 plus e raised to zi. E raised to zi by 1 plus e raised to zi. This is because this can be written as 1 by 1 plus 1 by e raised to z is equal to 1 by e raised to z plus 1 by e raised to z is equal to 1 by e raised to z plus 1 into e raised to z. That is e raised to z by 1 plus e raised to z. So 1 by 1 plus e raised to minus z or is equal to e raised to z by 1 plus e raised to z. This equation is known as the cumulative logistic distribution function. The cumulative logistic distribution function. Now you can easily verify that as zi ranges from minus infinity to plus infinity. Z ranges from minus infinity to plus infinity means x ranges from minus infinity to plus infinity. E raised to minus z ranges from Let me consider this more clearly. Z is equal to beta 1 plus beta 2 xi. As z ranges from minus infinity to plus infinity, Pi ranges between 0 and 1. Pi ranges between 0 and 1. For example, as x approaches to infinity, plus infinity, z approaches to plus infinity and e raised to minus z, e raised to minus z is 1 by e raised to z approaches to 0. So p approaches to 1. Similarly, as x approaches to minus infinity, z approaches to minus infinity, e raised to minus of minus z is equal to 0. That is equal to e raised to z approaches to, it increases indefinitely so that p approaches to 0. So as z ranges from minus infinity to plus infinity, p ranges between 0 and 1. P ranges between 0 and 1. Second, pi and xi are non-linearly related. So these two conditions are satisfied. We have satisfied the requirement that p lie between 0 and 1. Also that pi and xi are non-linearly related. But when these two conditions are satisfied, we have created an estimation problem. The problem is that pi is non-linear, not only in xi but also in beta 2. So pi is non-linear not only in xi but also in betas, beta 1 and beta 2. That means we cannot apply OLS because it violates one important assumption of the classical linear regression model, namely that the model is linear in parameters. But this problem is more apparent than real, and we can linearize this model very easily. What I say is, you cannot estimate this model as such. The reason is pi is non-linear not only in xi but also in betas. Even though the requirements that pi is non-linearly related to xi and pi lie between 0 and 1 are satisfied. But this model is, as we have discussed earlier, intrinsically linear. That means we can linearize this model by giving a suitable transformation. Let us see what is the transformation. Suppose that pi is the probability that the event will occur. In our home ownership example, for example, the family own a house. Then 1 minus pi is the probability that the event will not occur. That means the family will not own a house. And this 1 minus pi can be written as 1 by 1 plus e raised to z. Pi is written as, we have written pi as e raised 1 by 1 plus e raised to minus z, and 1 minus p as 1 by 1 plus e raised to z. Let us see why this is equal to this. We know that pi plus 1 minus pi is equal to 1. So pi plus 1 minus pi is equal to 1 by 1 plus e raised to z plus 1 by 1 plus e raised to minus z. I will be considered is equal to 1 plus e raised to minus z plus 1 plus e raised to z by 1 plus e raised to z into 1 plus e raised to minus z. We take this as the LCM. So multiplying to this and to this, 1 plus e raised to minus z, 1 plus e raised to z. This is equal to 1 plus 1, 2 plus e raised to minus z plus e raised to z divided by 1 plus e raised to minus z plus e raised to z plus e raised to z into e raised to minus z. Cross multiply. And this is equal to 1 because a raised to m into a raised to n, a raised to m plus n. This is 0. So 1. So you have 1 plus 1 is equal to 1. So if Pi is 1 by 1 plus e raised to minus z, 1 minus P is 1 by 1 plus e raised to z because adding together will give you 1. Now given this, we write Pi by 1 minus Pi as 1 minus Pi as equal to 1 by 1 plus e raised to minus z all divided by 1 by 1 plus e raised to z is equal to 1 by 1 plus e raised to minus z into 1 plus e raised to z by 1 is equal to 1 plus e raised to z divided by 1 plus e raised to minus z is equal to 1 plus e raised to z divided by 1 plus 1 by e raised to z is equal to 1 plus e raised to z divided by e raised to z plus 1 by e raised to z equal to 1 plus e raised to z by e raised to z plus 1 into e raised to z by 1. So these two terms will cancel. Pi by 1 minus Pi is equal to e raised to zi. That is equal to e raised to beta 1 plus beta 2 xi. Pi by 1 minus Pi is equal to e raised to beta 1 plus beta 2 xi. So let me write Pi by 1 minus Pi as equal to e raised to beta 1 plus beta 2 xi. Now what is this Pi by 1 minus Pi? This Pi by 1 minus Pi is known as odds ratio. Pi is, as an example, is the probability that a family will own a house to the probability that it will not own a house. So it is the odds ratio. For example, if Pi is 0.8, you will get it as 0.8 by 1 minus 0.8. That is 4. The odds are 4 to 1 in favor of the family owning a house. The family owning a house. If you take the log of the odds ratio, Li is equal to ln Pi by 1 minus Pi is equal to beta 1 plus beta 2 xi. This Li is, so what is L? L is log of the odds ratio. And as you know, Li is equal to beta 1 plus beta 2 xi. So log of the odds ratio is linear, not only in x but also in the parameters. And L is known as Logit. L is known as the Logit. So the name Logit model. This is what we estimate if you have data with the y taking the values 1 and 0, x any number of explanatory variables. What you are estimating is this. You are estimating the log of odds ratio, that is ln of pi by 1 minus pi. I will explain this point with a real world example. Anyway, this is what you will obtain from econometric softwares. Now let us see what are the features of this model. As you can see, as p goes from 0 to 1, that is as z varies from minus infinity to plus infinity, L also goes from minus infinity to plus infinity. So even though p lie between 0 and 1, L is not bounded by 0, 1 values. Then L is linear in x, but probabilities are not. Probabilities are not. This is in contrast with the LPM. In the LPM, probability is linearly related to x. Here, Logit is linearly related to x. P is not linearly related to x. And it can be shown that dp by dx is equal to beta 2 into p into 1 minus p. So dp by dx is not a constant. It varies from point to point depending on p. So a third one is, here we have introduced only one x. The model can be extended to include any number of explanatory variables. Then when L is positive, it means that when the value of x increases, the odds of the regressant equals 1 increases. If L is positive, when x increases, the interpretation is the odds of the regressant to become 1 increases. And if L is negative, the odds that regressant becomes 1 decreases. And a more formal interpretation is like this. Consider beta 2. It measures the change in L for a unit change in x. That is, it tells us how the log of the odds ratio changes as income changes by, say, 1000, like that. Also, given a certain level of income, we can calculate the corresponding logs. We can also estimate the corresponding probability, etc. from the original model. Pi is equal to 1 by 1 plus e raised to minus of, that we have done in the last class. And in the LPM, Pi was assumed to be linearly related to x, but in the Logit, L is assumed to be linearly related to x. Now, the question is how to estimate the model. We cannot estimate it using OLS because dependent variable is ln pi by 1 minus pi. If the family own a house, it becomes pi is 1 by 0, not on 0 by 1. So 1 by 0 and 0 by 1 are not sensible. So OLS cannot be used. What is used is ML. But fortunately, we have softwares. Softwares will automatically calculate this model for us. So we need not to worry about this. And as we have discussed earlier, R square is not very important in the qualitative response regression models. conventional R-square cannot be used. Instead, we use what is known as McFadden R-square, pseudo R-square, etc. That we will discuss in the context of an example. Also, to estimate the significance of all the coefficients, we will not use F, we use its alternative, the likelihood ratio test. Because the model itself is non-linear, to test the significance of such models, we use the likelihood ratio, Wald, Lagrange multiplier test, etc., which we have discussed in the context of the method of maximum likelihoods. So to clarify the points and how we report the result from Logit, Probit, etc., in the next class we consider a concrete example. Then only the points will become clear to you.